important topic is relationship between f and chi-square distribution. Here we have two types of relations. First one is f and chi-square, and f and t distribution also we exist. But this f and chi-square is very important. And before going to this topic, we have to learn some formulas. Beta of m comma n equal to gamma of m into gamma of n by gamma of m plus n. This is our first formula. And the second formula is limit n tends to infinity, gamma of n plus k by gamma of n equal to n power k. Third formula, limit n tends to 0, 1 plus k by n whole to the power n equal to e power k. Here we can write this gamma like this, or like this also we can write. In these two ways we can write any one. This one is represented as gamma only. First we have to learn the statement. After that we can move to this relationship. Statement for relationship between f and chi-square distribution. In f distribution, if f equal to chi-square by n1, here we have to replace, in place of f distribution, capital F equal to chi-square by n1 and n2 tends to infinity. n2 can be equals to infinity. Then this distribution changes as a chi-square distribution. This is our statement. First we have to substitute in place of f chi-square by n1 with using before we already known three formulas. First one is beta of m comma n equal to gamma of m into gamma of n by gamma of m plus n is our first formula. So here we have to substitute that formula, and the PDF of f distribution is n1 by n2 whole power n1 by 2 by beta of n1 by 2 comma n2 by 2 into f power n2 by 2 minus 1 by 1 plus n1f by n2 whole to the power n1 plus n2 by 2. This is our degrees of this is our PDF, so that we have to write df. And now I am just replacing capital F equal to chi-square by n1. Here n1 by n2 whole to the power n1 by 2 by, we already known beta of m comma n, gamma of m into gamma of n over gamma of m plus n. Here I am substituting this formula and the denominator. So it is gamma of n1 by 2 into gamma of n2 by 2 over gamma of n1 by 2 plus n2 by 2. Next, in place of f, I am just replacing this chi-square by n1. So chi-square by n1 whole to the power n2 by 2 minus 1 whole divided by 1 plus n1 into, here it is f, so we can write chi-square by n1 by n2 whole power n1 plus n2 by 2 into d of chi-square by n2. This is our first substitution. Next we have to simplify this. Later we have to take as n tends to infinity. For this continuation, here it is f of f. So n1 by n2 whole to the power n1 by 2 into this is like 1 by a by 2. Here we can write this as 2 by a, 1 into 2 by a, nothing but 2 by a. Like that I am just changing this gamma of n1 plus n2, because both the denominators are same, so that I am just adding, divides gamma of n1 by 2 into gamma of n2 by 2 into chi-square by n1 whole to the power n2 by 2 minus 1 divided by 1 plus, here this denominator n1 and the numerator n1 both will cancel. Chi square by n2 only remains. Whole to the power n1 plus n2 by 2 into d of chi square by n2 and that multiplication. This is our first part. Here we can split. One more step we can write n1 power n1 by 2 by n2 power n1 by 2. I am just splitting this power value differently. Gamma of n1 plus n2 by 2 by gamma of n1 by 2 into gamma of n2 by 2 into chi square power. This one also I just want to split it. 1 by n1 power n2 by 2 minus 1 into numerator chi square whole power n2 by 2 minus 1 into 1 by 1 plus chi square by n2. I am just writing in the down. All these are in multiplications only. Don't get confused. One by 1 plus chi square by n2 whole power n1 plus n2 by 2 into d of chi square by n2. This is our first equation. Here, wait a minute. Here we have to apply limit n tends to infinity for the first part. I am just applying for limit n tends to infinity gamma of n1 plus n2 by 2 by n2 power n1 by 2 into gamma of n2 by 2. Here this looks like limit n tends to infinity gamma of n plus k by gamma of n. Here I am just keeping this same n2 power n1 by 2 into n power k. In place of n, here it is n1 by 2, n2 by 2. n2 by 2 whole to the power. In place of k, here we have n1 by 2. So we have to split like this. Now we can split the numerator and denominator individually. n2 power n1 by 2 by 2 power n1 by 2 whole divided by n2 power n1 by 2. Here both the numerator and denominator same. So 1 by 2 power n1 by 2 is the answer for this part. Next part. We have to consider the next part. Next part is limit n tends to infinity 1 plus chi square by n2 whole power n1 plus n2 by 2. We can split this power in two terms and we have to split this limit also for two terms. Limit n2 tends to infinity 1 plus chi square by n1 whole power n1 by 2 into limit n2 tends to n2 at here. Limit n2 tends to infinity 1 plus chi square by n2 whole power n2 by 2. Here we have third formula, limit n tends to infinity 1 plus k by n whole power n equal to e power k. We can write here n1 and n2. These two are different. This is equals to 1 into this. Here limit n2 tends to infinity 1 plus chi square by n2 whole to the power n2 by 2. Chi square is a k. N in place of n, there we have n2. So we can write it as e power k is chi square whole power n. So we can write this formula. Finally, limit n2 tends to infinity 1 plus chi square by n2 whole power n1 plus n2 by 2 is equal to e power chi square by 2. Now we have to substitute this formula and the before formula, these two in equation 1. From equation 1, we are taking from the equation 1 f of f equal to n1 power n1 by 2 by gamma of n1 by 2. Here we substituted this in place of gamma of n1 plus n2 by 2 by gamma of n1 by 2 into gamma of n2 by 2. In that place, we are just replacing this value. Next, in the next part, we are just replacing this e power chi square by 2. Now I am just writing again gamma of n1 by 2 into 2 power n1 by 2. This e power chi square by 2, this one is in denominator. If it moves to the numerator as e power minus chi square by 2. Now we can write it as n1 power n1 by 2 into chi square power n1 by 2 minus 1 by n1 power n1 by 2 minus 1 into d of chi square by n1 moves as power 1. This is our plus 1. Now we can substitute, simplify this gamma of n1 by 2 into 2 power n1 by 2 e power minus chi square by 2. Now this negative and positive will cancel and this both two terms will be cancelled. Chi square power n1 by 2 minus 1 into d of chi square will exist. Finally, this is our chi square distribution PDF. This is f of capital F. From F distribution, we obtained chi square distribution. This is the PDF of chi square distribution. Chi square distribution with only n1 degrees of freedom. We had only 1 degrees of freedom as n1. So f1 by gamma of n1 by 2 into 2 power n1 by 2 into e power minus chi square by 2 chi square power n1 by 2 minus 1 into d chi square. This is our chi square distribution. This is our important relationship between f and chi square distribution. Relation between f and t distribution. This is our second relationship. Our statement is in f distribution n1 equal to 1 and n2 equal to n, f equal to t square. We have to substitute these three values in f distribution, then it gives the t distribution. So first we have to write the PDF of t distribution. We already known that PDF of f distribution is f of capital F equal to n1 by n2 whole power n1 by 2 by beta of n1 by 2 comma n2 by 2 into f power n1 by 2 minus 1 by 1 plus n1f by n2 whole power n1 plus n2 by 2 into df. First we have to substitute in place of n1 1, in place of n2 n, 1 by n whole power. In place of n1 we have to substitute 1. So 1 by 2 by beta of 1 by 2 comma n by 2 f power 1 by 2 minus 1. Here we have to substitute in place of f t square. T square whole power 1 by 2 minus 1 into 1 plus 1 into t square by n whole power 1 plus n by 2 into dt square. We have to differentiate the t square. Here 1 by n whole power 1 by 2. We can write it as 1 by root n into beta of 1 by 2 comma n by 2 into t power t square whole power 1 by 2 minus 1. It is minus 1 by 2 by 1 plus t square by n whole power n plus 1 by 2. 1 plus n by 2 and n plus 1 by 2 both are same. We have to differentiate this. So 2 into t into dt. We can get this. After that, we have to simplify this one. So f of capital F equal to 1 by root n into beta of 1 by 2 comma n by 2 into t power. Here both numerator and denominator having same. So t power minus 1, 1 plus t square by n whole power n plus 1 by 2 into 2t dt. 1 by root n beta of 1 by 2 comma n by 2 into 1 by 1 plus t square by n whole power n plus 1 by 2 dt. Here we can write this t power minus 1 as 1 by t. 1 by t into t. Both will get cancelled. This is our final t distribution formula. So finally, f of capital F equal to 1 by root n into beta of 1 by 2 comma n by 2 into 1 by 1 plus t square by n whole power n plus 1 by 2 into 2 dt. Here 2 will disappear since the total probability is 1 only. So we don't take that 2 value. So here this 2 factor will disappear. Why? Because the total probability is 1. Finally, f of capital F equal to 1 by root n beta of 1 by 2 comma n by 2 into 1 by 1 plus t square by n whole power n plus 1 by 2 into dt. This is our PDF of t distribution with n degrees of freedom. With n degrees of freedom. This is our relationship between f and t distribution.